Okay, method of common bases. Now, number one is kind of the essence of this and strategy, how to approach these questions. We have 2 to the negative 2k equals 2 to the negative 3k minus 3. Each of those exponentials have a base of 2. And we see here it says that they are equal. So if those two exponentials are equal, and the bases are already equal, they're both 2's. If the bases are equal, then in order for everything to overall be equal, if the bases are the same, the exponents must be the same. They also must be equal. I'll add 3k. Done. They wouldn't be that easy on the regions. That's just kind of to show you the idea. Now on 2, as we see, the bases are not the same. So what you got to do, if you can, drop one base down to a power of the other. 64. You don't have to write this down every time. I'm just illustrating. 64 is for the third power. 4 times 4 is 16, times another 4 is 64. So all we got to do here is just replace, and this is what you have to show. That's like the bare minimum amount of work here so far. 64 is for the third power. Now we have equal bases, so now our exponents must be equal in order for everything to be equal. If negative x is 3, x is negative 3. So 3 is another pretty easy example here. They don't match, so I got to drop one of them down to the other. That's the easiest way to do it. 5 squared is 25. Hey, now my bases are equal, so the exponents are equal. Drop the bases, make a big equation out of the exponents. Divide by 3, 2/3. Now, the next one is where we got to be careful. 9 to the first is 9. 9 squared, 9 times 9 is 81. So I can't drop the 27 down to a base of 9. However, I can drop them both down to a base of 3. 3 squared is 9. 3 cubed is 27. 3 cubed is 27. 3 squared is 9. And now this is why, part of the reason why we reviewed those exponent rules. Power to a power, I multiply. But we got to multiply that 3 by both the 2m and the 2. So we're distributing here, kind of. Now our bases are equal. So now I can say exponents are equal. 2-step equation, subtract 6. Divide by 6. Reduce that down, negative 2/3. Now 5. 64, like we've seen, that's already we can drop that down to a power of 4. What some people said when we went over this was, hey, couldn't you drop them both down to 2? 2 squared is 4. And then you could get there eventually with 64 as well. And yeah, that'd be fine. Well, I'll just do it the quicker way. Ooh. Dropping both down to 2, there'd be absolutely nothing wrong with it. But I'll just go the quicker way. Power to a power, we multiply on that right side. If the bases are equal, then the exponents are equal. I'm going to add n, divide by 5, to negative 5. Oh, now number 6 is another one where we got to drop them both down because 125 squared definitely isn't 625. We can drop those both down to a base of 5. 5 cubed is 125. 5 to the 4th is 625. Power to a power, multiply. Now don't forget on the right-hand side, we're multiplying the inside exponent times the outside one, but the outside one's a binomial, so it's like you're distributing. We can set them, the exponents, equal to each other. I'm going to add the 12x, divide by 18, reduce that down, 2/9. You end up getting a lot of fractions for these as well. Now, 7 throws another curveball at us. I can drop 16 down to a power of 2. 2 times 2 is 4, then another one 8, 16, so that's 2 to the 4th. But if you 2 to the 4th on the bottom, so here's another reason why we went over those exponent rules again. I want the 2 up on the top, so I can say that my bases are equal. Right now, one base is a 2, which is 2 over 1, and the other base is on the bottom, so it's like a base of 1/2. That won't work, but like we said, we can send that up to the top, make it negative. 2 to the negative 4th is like 1 over 2 to the 4th. This helps me. Now my bases are exactly the same, so I can just set them equal. X equals -2. Similar idea on 8, but there's one other thing on 8 we have to worry about. And this is just a careless mistake that people make. When we get 16s and 64s and 8s and everything, people forget what exponents mean. 8 squared is not 16. That's 64, like on the left side. I can't drop 16 down to 8 squared. Some people do that even on a question like this, just on accident. So you gotta be careful. And again, we could do 2. However, I am going to do 4. (16) is 4 squared. Now, at the same step, I'm going to multiply on the left. And flip that up with a -2 on the right. Now they're the same. The bases are the same, so my exponents are the same. Divide by -9. Negative divided by negative, positive 2/9.